Hello, everyone. It's my pleasure to be your first presenter with the topic AI and ML with Python 3.14. So, I was already introduced. I am senior data engineer here at Grid Dynamics. And why this topic is important, why I will speak, and why I will waste time for this? Because in the last 4 years, Python has got 50% faster. 93% of which points are over improved. From these 93%, 84% are over 50% and 80% are over 100%. So here in the slide, you can see how Python consistently is improving itself. It's consistently becomes harder, better, faster, and smarter. So what we'll talk today? To talk about the evolution of AI and ML frameworks in the Python, what's the new in the Python 3.14 and 3.14, and libraries and how Python changed them. So the evolution of AI. I will start with Python 2 array, but before I go on deep, I want to ask if anyone from you has worked with Python 2. So please raise your hands. Cool. Yeah, I see some hands. Cool. Yeah. So the Python 2 era was the rise of traditional machine learning libraries and numerical operations. Important libraries from this era, we have SciPy, which was introduced in 201, and NumArray, which was a producer of NumPy. NumPy, everybody knows NumPy. sklearn for traditional machine learning, PyBrain, which was first, and yeah, deep learning, and it started in Python 2. So first steps of deep learning, it's not in Python 3, it started in Python 2, and Fino, which was an open source library for numerical computation. So Python 3 area. For Python 3 area, also please raise your hands if you worked with Python 3. Yeah, okay. Yeah, I see the trans here. So the Python 3 areas for deep learning revolution and beyond. Here we have more libraries, and I'm not going all of them. I just want to group. We have deep learning. From deep learning, we have Caffe, Keras, TensorFlow, Transformers, PyTorch. We have traditional machine learning. From traditional machine learning, we have gradient boosting, which is XGBoost, LightGBM, and CatBoost. And also you can see we have AutoML from PyCaret, and we have H2O AutoML. So what's the new in Python 13 and 14? I will start with the most interesting, which is PEP 703. It's making the global interpreter log optional in Python, in CPython, if we speak concretely. So if anybody doesn't know about GIL, check it out. It's a global interpreter log that prevents multi-threading. So what's the motivation behind this PEP? The motivation is the GIL makes many types of parallelism difficult to express. The GIL affects Python library usability, which is strange because if we speak about GIL, we think about performance usability, not the library usability, but a lot of people who is working on libraries were saying the GIL is impacting us, and someone have skipped about Python, even if the library is not written in Python, they say, oh, Python maybe it's not good for multi-threading. So GPU-heavy workload requires multi-core processing, and the GIL makes deploying Python AI models difficult. Next one, which is most hyped PEP, I think, it's PEP 744. It's JIT compilation, just in time. Before I go in deep, I need to say that JIT is experimental, so it's disabled by default and will be enabled only when two conditions are met. First condition, it will bring speed and optimization up to 5% of all. And second optimization, it will be enabled if the JIT enables, doesn't bring and don't break anything. So what's the motivation behind PEP, behind JIT is traditional CPython execution was untyped, enlarged, and optimized, which was until Python 11, which brings us to PEP 659, specialized adaptive interpreter. I will speak in depth about this in some moments. And we have CPython DCL. DCL stands for domain specific language. So how does JIT work? What you need to know from JIT, it will speed you only if you have repetitive processing, like for loops. Like I said, in Python 3.11, we had specialized bitcode. For this regular code, we have this type of bytecode. I don't want to go in deep. I will just highlight binary of familiarity. So in Python 3.10, we didn't have binary of subtract float. I mean, we had, but bytecode was not doesn't have information about this. So in Python 3.10, we had just binary op, and binary op. In Python 3.11, we already know from binary op familiarity what element to take, which is binary op subtract float, binary op add int, and binary op through diff int float. Next, in Python 3.12, we have micro operation. We didn't speak about tier 2 optimization yet, but it's coming. So the micro ops is nothing but the same specialized, the same bytecode presented here, but in a tiny uniform micro operations. So these micro ops are generated by Python 12 DCL, and almost every micro operation starts with check validity and set API. Next, as you can see, we have a lot of duplicates. So why don't we optimize it, which is what brings Python 3.14. It tried to optimize a bit. So from optimization, we have check validity and set API. Some of the micro operations are deleted entirely, like this one, check PEP, and guards. And this is the cheat, the ultimate optimized micro operation after the JIT. So you can see the difference between Python 3.14 without JIT and with JIT. So like I said, just-in-time compilation worked only with iterators and repeatable process because it optimized the code once it became hot. What means the code is hot? For example, I will go to this. Let's assume we have task and count to be integer. It's okay for us. So if we process 100 iteration and it's int, the JIT will try to understand, hey, it's integer, I know about this. So why I don't copy the most interesting bytecode for me, and after this, patch it with new values. This is how JIT works. It works with algorithm copy and patch. So it's copy the most hot bytecode and patch it with new values. What will happen if, let's say, for 101 iteration, one card will not be integer, but let's say string, or no, string will go value, let's say float. It will go to decompilize. So JIT optimize only in the best case when we have the same types. We don't care about values, we care about types. If so by somehow process, like in NumPy or some other operation, the type will change, the JIT will try to decompilize and de-optimize everything. So don't take JIT as a magic pill. No, it's not gonna work like this. You're not going to enable and see the speed. Another PEP is PEP 741, which is Python 3.14 version. It's Python configuration C API. This PEP just unifies the configuration of pre-initializing and initializing in C Python in one single API. So now let's talk about how libraries and how Python 14 change them. Why I will speak about only Python 14? Because half of the top machine learning, and not machine learning, but top libraries are supported from Python 3.14. And for Python 14, we have just 2%. 8 packages, that's all. I will start with NumPy. So what's here? Here is the implementation of PageRank in Google. This is a good example because it has matrix operations. It works with large data and can be easily parallelized. From here, we can see for single threads and process, but without enabling new build options for Python 12 and 14, we have the same result. And if here the threads, we can see the no-kill version is the fastest, which you can again speak about no limiting the parallelization in multi-threads. It is good. So let's go to our next library. It's Hitler. And here we can see something interesting. The 12 version is faster than 13 version, even if I stipulate the 14 version is faster. Yes, this is the case, but not always, which I, another point, don't see if you're going to switch from 12 to 13 version, you will have an increase. Not really, not always. And the same pattern here for threads. NoGill is still good and still working. PyTorch, the same pattern like scikit-learn. We can see 12 version is faster. In the process, we don't see a lot of changes. And for threads, still NoGill. So the previous examples show how a version without NoGill speed up multi-threading process. But don't think it will solve always. This is, again, not a magical pill. Here we can see Dask. From Dask family, we see Dask array. And from threads, single and process Python 14 version with GIL and NoGill is slowly by 0.5% if you compare with 12 version. Another point here, you cannot take advantage of Python optimization if your libraries aren't written in Python. So from XGBoost, LightGBM, and CatBoost, we're neutral. We don't care because we're completely mostly in C++. Even more, don't forget, half of versions of libraries are not supported. So one example, one of many examples, TensorFlow, which is not supported in Python. They are working on this, but I think it will be by the 2026. So what's the conclusion? Python has become faster, not because of some magic, but of the optimization of internal process, which is detected by the simple what Python is maturing and it's more independent. We see a good trends what most library related to AI and ML try to build and to be written in Python, not in C, not in C++, but in Python itself. We have PyPy, a new version of, okay, not it's a new, but a version of Python written in Python. So what's next? The new version of Python will improve the JIT and GIL. If you don't believe me, check out the PEP 788, which is a PEP related to Python 3.15. Sorry. So we will see new achievements that will make Python even harder, better, faster, and smarter. Questions? Yeah.
We lose something during this process.
We lose, yes. We will. What we are losing? We are gaining only in good cases, like JIT is good only if it's repeatable, and for JIT it takes up to 10% more memory. So from the CPython clusters benchmark, we see what Python without JIT and the JIT, they have different memory, because JIT tries to take up to 10% more memory. Yeah, the JIT is good. Besides this JIT, like in fact, it might bring new injections because this code can be gained and can be executed by someone else. Another, GIL, it's a good question about GIL because I had some problems. Some libraries worked with Python 3.13, but didn't work with Python NoGill version. I'm speaking about JAX, which I didn't include. So we are gaining speed only in best case. If worst case, we are de-optimizing everything, and de-optimizing takes a lot of memory and a lot of time. Another questions? Okay, if no more questions, which is the bibliography I use it. I really recommend everyone to watch the talk from Brett Baker, which is the guy who created the JIT in the Python. He's the guy who opened the pull request. I'm not saying he's the only one, but he's the main. About his building a JIT compiler in CPython, and the article about how Python 3.14 gets a JIT. Thank you for your attention.